So guys, this is our limit switch and these are the two LEDs I am going to use here. This LED is on when the button is not pressed, but as soon as the button is pressed, the other LED turns on and this one turns off. See, simple as that. So that's how our limit switch is going to work. So let me show you the code. So you can see that what we did here is that this over here is a command which will declare one LED as output, second LED as output, the button pin as an input. Then we check if the button is pressed. Once the button is pressed, then we turn on first LED and the other LED is off. And if the button is not pressed, else the other LED is on, that is B.F3 is on and the previous LED is off. So this simple code gives us this result, that our protection system device, that is our limit switch, is working like a charm. This is a very powerful device, especially when you are dealing with the protection system for your machines or any other task. Then this limit switch is of great importance. Hello guys, welcome to learning microcontrollers. In this video, I will show you how we can interface a limit switch with a PIC16F877A microcontroller. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP variant. And guys, this is the limit switch I'm talking about. It is available in various sizes, small, medium and very small micro type. So you can use any type of limit switch. I'm going to use this one because it is a heavy limit switch, big one. So even if you use a smaller one having 2-3 pins, doesn't matter. So in this type of limit switch, you will have two contacts. This one, let me name them like this. I name the one as signal, center one as not connected, right one as the VCC. The center one do have some purpose, but right now for us, it is not connected. We are only going to use this one and the VCC one, the rightmost one. So you can shuffle these two as well. You can make this one the signal and this one the VCC, doesn't matter. So this will only do the continuity. Like once the button is pressed, it is continuous. Now the current will flow. Once it's disconnected like a normal switch, it will disconnect the circuit. So that is what our limit switch does. Now guys, let's connect it with our PIC16F877A microcontroller. So for that, we will need a 10 kilo ohm resistor. Now guys, VCC will go directly to the VCC of the PIC. We will run this button using 5 volt. And then for the signal, you connect it to the one end of the 10 kilo ohm resistor like this, and from the same pin you will take out your output. For the output, you can use any available digital input output pin of the PIC. I am going to use the pin number D1 like this. Now guys, from the other end of this 10 kilo ohm resistor, you send it to the common ground like this. In this way, our limit switch is connected. So you can get the limit switch for various sizes. All you have to do is to check the continuity, that whenever you press the button, which two pins get shorted, and when you release the button, which two pins get on, like opened. So that's what you just have to do if you have a different type of button. If you have the same button, then follow the same pin configuration and connections. Now guys, these limit switches are used in machinery, especially to set the offset values, like the CNC machine is going out of limit, then you have this button over there as well. Like you are making a small machine, it will work as a protection system device. Like you will add them at several places, that if your motor is going out of the limit, this will be pressed and your PIC will stop the whole circuit, or the system will go in emergency state, etc. So simple as that. Now guys, for the output purpose, we will be using two LEDs. So what these LEDs are going to do is that I will program this PIC in such a way that by default this LED will be on, but as soon as the button is pressed, this LED will turn on and the other LED will turn off. Simple as that. One will be on when the button is not pressed, and the other one will be on when the button is pressed. Simple as that. So let's do the connection of the LED. As you can see guys, LED has two pins, one longer, one shorter. I label them like one as the power and other one as the ground. The longer pin is the power and the shorter one is always the ground. And remember, you cannot shuffle these two pins because this LED is a polar component. Now guys, to connect the LED with the PIC, you will need a resistor. This is a safety resistor. It will limit the current. So its value can be from 100 ohm to up to 500 ohm. Depending upon the availability of resistor at your place, you can go even for higher values, but remember that higher the value of this resistor, the dimmer the LED will go. So I'm going to use a 220 ohm resistor. It's an ideal value, or for me it's an ideal value. You can use the same. So let's do the connections. Now for the top LED, connect the longer pin, that is the power pin, to the one end of the 220 ohm resistor like this. Now from the other end of this 220 ohm resistor, connect it to any available digital input output pin of your PIC. I'm going to use the pin number B3 like this. Now guys, for the lower LED, do the same. Connect the longer pin to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, you can connect it to any available digital input output pin of the PIC. I'm going to use the pin number B2 like this. Now guys, for the ground pin, short them like this and then you send it to the common ground of the PIC like this. In this way our connections are completed. So let me introduce you to the hardware before we move on to the programming. So guys, this is our hardware. As you can see, this is the limit switch I have here. As you can see that it's a simple limit switch, easily available in the market, and you can buy the smaller one as well. It is also available in the smaller version as well. Also it will have the same configuration. See, only two wires are connected because whenever the button is pressed they both get shorted, else these both pins are opened. Now two LEDs, this and this LED will be used, simple as that. Now guys, this was our hardware. Let's move to the micro C4 PIC to begin the programming. Now guys, this is our micro C4 PIC. Let me zoom in so you guys can see better. So the vision over here is 7.2.0, that is I am using. You can use a higher vision as well if it's available. Latest is always better, remember that. So let's get started. Click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project. I write Limit Switch Tutorial by Learning Microcontrollers like this. Now guys, here this is the path of the project where your files will be created, and the microcontroller I am going to use is PIC16F877A. Then guys, the crystal that I have on the hardware is 13 at pin number 13 and 14 is a 20 megahertz crystal. So I will write 20 here. Whatever the crystal you have with your PIC16F877A at the pin number 13 and 14, you will write that value over here. Click on Next and finish. Now guys, this window pops up. Before you do anything else, first of all, save your work. Press Ctrl S. Now the work is saved. Now guys, first of all, we have two LED pins. Let's initialize them. So I write this B.F2 equals to 1, and initially the LED must be off. B.F2 equals to 0. Now this one, because this register is there to define the direction of the pin, and the LED pin must be output. We have LED here, so this must be output. So this register defines the direction of the pin. So B.F2 is the pin, this is the register, 0 means it's an output and 1 means it's an input. So pin is declared as output because we have LED on this pin. Initially the LED must be off, so B.F2 equals to 0. Now guys, give some initialization delay. This is not necessary, but I always suggest to give it in the one time loop like this. Now guys, for the second LED, just copy paste this. At pin number B3, I do is that I copy this and I make it B3. That's it. Now the second LED is initialized as well. Now guys, for the input pin, that where our limit switch is connected is D1. That is the pin number 20 of the PIC16F877A. So I write, or we simply copy paste above like this. Now here we change the pin name. Instead of B.F2, we make it D.F1 because it's pin number D1. And the pin is declared now as input. Why? Because it's a button. And button is always connected to an input pin because it will give the input to the microcontroller. So trace D.F1 equals to 1. This means that trace is the register, D.F1 is the pin, and it is being declared as input like this. Now guys, initial state of this pin must be D.F1 must be 0. Why? Why 0? Because, let me show you why it must be 0. Now see that this grounding resistor, like see that signal pin goes to this pin over here, and then this 10 kilo ohm resistor is at the grounding end. Whenever this 10 kilo ohm resistor is at the grounding end, this means that whenever the button is pressed, a 1 will be sent. So if a 1 has to be sent when the button is pressed, then by default our pin must be at 0. So 1 will be sent when the button is pressed. So by default it must be 0. So that's all. That's why it is 0. Now guys, we have our two LEDs initialized and we have our limit switch initialized. Let's move on to the forever loop. Write down while 1 and starting here, ending here. So this will be our forever loop. Let's do the programming. So first of all, we check if the button is pressed. So I write if port D.F1 double equals to 1. So if the button is pressed, we wait. If the button is still pressed for more than 50 milliseconds like this. Now if the button is pressed, then we wait and we again check for the button to be pressed again. Then we consider it to be pressed. Now why this small wait? Because there is a possibility that because of some random like phenomena like static shock, or because of some dust particle in the air, or because your button is too old, some grease type thing, etc., your button may get shorted and it will initiate the task inside the loop. So to save yourself from that auto triggering, we use this delay. So if the button is pressed for more than 50 milliseconds, only then it will be considered as pressed. So if there is a static shock that is not more than like 4 milliseconds, static shock will take it will be very quick. So this 50 millisecond means that the button is being pressed by some valid phenomena like a human hand. In our case, we are going to press it by our hand. So our hand will press the button for more than 50 milliseconds in any case. So that's why we will wait. If the button is pressed, we wait for 50 milliseconds. If it is still pressed, then we consider it to be pressed, and then we turn on an LED. The LED at port B.F2 is on now. We make it 1, while the other LED, that is B.F3, is off. As told you earlier, one LED will turn on, another will remain off when the button is pressed like this. Now guys, else if the button is not pressed, then the other LED will turn on and B.F2 will turn off. Now the other LED will be on if the button is not pressed. So we switch this. Now B.F2 is off and B.F3 is on. Simple as that. Now we build this code. It's built successfully without any error. Now I zoom out. Let's burn it. Go to the PIC16 programmer tool. Click on File, Import hex file. This limit switch tutorial by learning microcontroller. This is the file we just created. Click on Write. Okay, the new file is being written. Let me zoom out and let's get to the hardware. So this is our hardware over here. Let's see, the code is being burned. Okay, the code is burned successfully. Let me power up the circuit using the PIC16 programmer tool. I click on this on. Okay, see, the LED is on. So this is a good sign. So by default, this LED must be on. But now when the button is pressed, the other LED will turn on and this will turn off. Let's see, does it work? See, it's working. I release it. See, it's working. See, it is working. So now this is just an example code for a tutorial purpose. Whenever you will integrate this button into your machine, etc., then you will do other tasks like you will turn off the motor or you will turn on the alarm, etc., when the limit is reached, or you will give a signal on the LCD, a warning or something, a cautious symbol, etc. Simple as that. So guys, see, this is how your limit switch is going to work with the PIC16F877A microcontroller or any microcontroller. So guys, this is it. So if you have any questions, you can ask in the comments. So thank you very much for your time, guys, and have a nice day. We'll see you in the next video.